Laws of motion and force. Everybody in this universe stays in a state of rest, i.e., no change in position of a body WRT time, or of uniform motion, i.e., change in position of a body WRT time. This chapter is concerned about the cause of rest or motion, i.e., force, and its effect, i.e., acceleration or deceleration, and their relationship. Newton's laws of motion. Newton's first law of motion. According to this law, an object continues in a state of rest or in a state of motion at a constant speed along a straight line, unless compelled to change that state by a net force. In other words, if a body is in a state of rest, it will remain in the state of rest, and if it is in the state of motion, it will remain moving in the same direction with the same velocity unless an external unbalanced force is applied on it. This law is also called law of inertia. It gives qualitative definition of force. Handy facts. A common misconception about Newton's first law of motion is that a force is required to keep an object in motion. This is not so. Experiments done on air tracks, where there is a negligible friction, show that no force is required to keep an object moving with constant velocity. We get this misconception because friction is always present in our everyday lives. Inertia and mass. A greater net force is required to change the velocity of some objects than of others. The net force that is just enough to cause a bicycle to pick up speed will cause an imperceptible change in the motion of a freight train. In comparison to the bicycle, the train has a much greater tendency to remain at rest. Accordingly, we say that the train has more inertia than the bicycle. Quantitatively, the inertia of an object is measured by its mass. Inertia is the natural tendency of an object to remain at rest or in motion at a constant speed along a straight line. The mass of an object is a quantitative measure of inertia. The greater the mass, the greater is the inertia of body.